Okay, so welcome back to the Pig Talk podcast. This is podcast number, I don't know, because we don't really schedule these things. We only do it if there's something interesting to talk about. So I've got John here from Framework in Canada. That's Framework without the S, because there's another North American brand called Frameworks who make also lugged tube-to-tube bikes, but they're more sort of downhill enduro-oriented bikes. But hey, I was a downhill rider before as a road rider. So Nico Mullally, if you're watching, please send me one of those and I'll test that. And just, you may have seen the last video, but John sent me that frame for free. Well, he obviously put his man-hours into it. There was no agreement, no promise of a review. Just write it and feedback. We've been talking for about a year, I guess, now. So let's just start off really briefly. Why did you send one to me? And how many man-hours did that take?
Well, I made you a full one before we switched over to the anodizing, so it's been a long process. But I think we started talking actually because I'm considering starting a YouTube channel, and I wanted your opinion on that as someone who does like technically oriented bike content. Our product is sort of technical in nature, and it's challenging to convey that on a website succinctly, So I chose you amongst some other reviewers, basically because I don't want a fluff piece. I'm looking for actual feedback from you in order to help improve the bikes. Obviously, I'm getting some exposure out of that. But yeah, the other main big name would be James Wong, who was at Escape Collective when I sent him the bike. He's someone who is not averse to giving negative feedback. So for me, it's I need something actionable, not just I'm trying to build a bike brand on a top quality product, and I need to know that it is that. My opinion is just one person's opinion. So it's good to get the feedback from a diverse group of people who are actually willing to give constructive criticism.
First and foremost, thanks very much, because it's probably the nicest thing I've been sent since I've had a YouTube channel.
Thank you.
But let's just dive in straight into the technical details, and we'll throughout this chat we'll figure out how you got into making bikes and a bit about your background. But let's talk about that organically rather than just going block by block. But why are you making lugged tube carbon bikes with aluminium lugs? Don't they just galvanically corrode and break like they did in the 90s? That were many of the comments that came to the first video, which I put up, which is basically just a quick unboxing and the first of many videos, I hope. And you came into frame building, if I'm not wrong, from a manufacturing engineering background, not a cycling background. You're not sort of like a die-hard cyclist. So tell us a bit more about that.
I've always ridden a bike, but I would never qualify myself as a cyclist. I kind of grew up riding a hardtail giant, just kind of punting around with buddies in some wooded trails. And I commute on a bike every day. I go on group rides and stuff like that, but I still wouldn't say that I'm die hard. I think I bought my first set of Lycra last season, so I'm 37, so it took a while to get to that. So yeah, you're accurate to say that I came kind of in the opposite direction to frame building that most people do. I think most indie frame builders get into manufacturing through bikes. I'm kind of coming at the other direction, where bikes have always been something that I've enjoyed. I run a machine shop with my wife. We do a pretty wide range of products, and I think we'll probably get into that in more detail. So for me, it's when you're running a job shop, you're always doing other people's work, and you're kind of at the mercy of them having successful businesses for you to have the work to keep feeding them, whether that's on the foundry side, so tooling, or production machining. So I think it's not uncommon for every kind of machinist to daydream about a product that keeps the machines busy in downtime, or really that they're potentially more passionate about than the day-to-day pieces. So it was one of those mid-pandemic stories where the business was up and down. I was in and out of school. Turned out I had a bit of free time on my hands and a bit of disposable income for the first time since starting this business, since it's pretty capital intensive and most of the machines are on financing. So it's I'm trying to get parts. I was riding a fixed gear bike at the time and couldn't get, a rear chainring. Just scouring the internet. And then I look behind me. I'm okay, you've got a CNC machine, just make one. And it kind of all started from there. Then it was, I want to get a new bike. You can't get bikes really. So I made one as sort of a one-off. I still have it. It's Rock West tubing that I bought from McMaster-Carr, which for international people is Amazon Prime for industrial products here in the States, or in Canada.
Well, we use it over here as well. I bought lots of things from it.
Their website is like amazing. Yeah,
It's a
you pay a
lifesaver.
premium. Yeah,
Yeah.
you definitely pay a premium for the convenience factor, but like you can download 3 models right off it. So anyways, I bought Rockwest tubing, machined a set of lugs, and kind of just used like spacer blocks to glue the frame up on my surface plate. And I think there's a bit of an uphill battle as a new brand, but also as you opened with, I think some of the concerns that people have with this style of construction. I've got to kind of re-educate people who haven't learned that things have changed since then. So, and that's okay. I kind of didn't realize how much of a bottleneck that would be, or perhaps it isn't. And there's just some people who want to say something negative, and you're never going to change their mind on that. Like they're set in their ways, and that's okay.
Good. Well, I said to you before the call, make sure you don't have your Haas CNC machines whining in the background. And John was pretty offended that I said he was using Haas CNC machines. So we can't hear the Matsuras, although they're turned off.
A cheap joke. I think Haas's are really, really, really good value, and there's certainly people.
It's not what you said before.
No. I know some people who are more talented than me running those machines, making pretty impressive parts.
Well, let's just take a minute at home, if you're listening or watching this, to realize John is very, very modest, and it takes a lot of skill, I think, to take a process which, I mean, what the product I've ended up with looks extremely high-end, boutique, artisanal, whatever keyword you want to put on it. But it takes a lot of skill to design that production process so that the skill is removed when assembling the bike. Like John said, anyone could come in with a few hours of guidance to put together one of these frames himself. But the skill involved in getting to that stage is where that is the artisan bit for me. It's designing the process. He said there's no 20 years of TIG welding experience needed, and if that guy goes off sick or takes leave, then the workshop shuts down, right? It's not like that. And that's the skill investment in the product for me, and that's why I think it's really clever. And I think a lot of people just see a bonded lugged frame and go, oh, they've been around since the 90s, or Colnago's doing that. But you've done it in such a way where you've taken a lot of risk out of it. But anyway, we'll come to those individual design features in a minute. But I think, don't be so modest. I think you need to... let's appreciate what you've done to get to this stage. But while we're all here watching the Peak Tool channels, because we're really interested in the technical stuff, so I'm going to run through a few features on the frame, and I'll drop in some closer videos and shots of the frame as I'm talking through this. If you're watching on YouTube, if you're listening on Spotify or something, then go and have a look on YouTube if you want those bits. But obviously in the first video, it was just a little showcase, a little unboxing. I was very excited to receive the frame. It's completely unscripted, that video, and pretty blown away by the finishing of the frame. Having looked a little closer, there are a few things that I've got some questions about. Some things I'm just, as an engineer, we're always critical of other people's work. It's in our nature. And I'm not a massive fan at the moment of this headset part, right? And I explained to you why yesterday. And I think you can explain this, but I'm just going to explain it very briefly to the people at home. So John's headset on his frame doesn't feature the traditional compression ring, which is the quite clever little widget with the split in it, which goes inside the conical inner race of the top bearing. And when you preload the headset, it takes any clearance out between the steering tube of the fork and the top bearing inner race, and that's how you eliminate any clunking. It's very good at allowing for all tolerances, all different types of bearings, all different types of steering tube outer diameters, and it takes some clearance out there. It's a clever design for mass production. However, John's system doesn't feature that. In John's inner what do you call this? The top bearing interface.
Just a bar. I call it a top cap, but it's
top cap. You've got a direct connection to the bearing, and the steer tube of the fork goes in this bit with no interface in between. And I said to you yesterday, I don't like that design for manufacturer, because you're relying on the third-party supplier, who is the fork supplier, to get their outer diameter of the steer tube exactly right every time. If it's slightly too big, it won't even go in. If it's slightly too small, it's potentially to have the fork wrapping around it. There's no compression ring to take out that clearance. So why have you gone for this system? Because no, I'll be honest, it doesn't sit right with me. But so tell us about that.
That's okay. I kind of naively started making bikes from a machinist standpoint of, if a seat tube is 27.2, that they mean that. But yeah,
It's
the
the bike
reality.
industry. Yeah.
The reality is, I remember I got my first fork. It's the Ritchie fork, and I put a set of calipers on it. I'm like, what the hell is going on here? Like, this is, am I crazy? This dimension isn't quite right. So I think your point is very sound. So I'll kind of step through it in a couple, kind of my logic for why I went that way. The steer tubes of all the forks that I've gotten that are like, we need, for it to work with our bikes, it's got to be the tapered 1.5 lower and 1 1/8 upper. They are actually relatively good by bike industry standards. I'd say they're way tighter across all the brands that I've seen than seat post diameters, for example. But I think that's because most factories now essentially machine the diameter of those after it's molded. You know, they're taking off any flashing, and it's a light, probably an abrasive process to take that down to size. And you can see that on some of the sort of lower quality ones where the ID and the OD aren't concentric. I don't think that's a result of the molding process. That's a result of like the post machining. And you can, if you know what you're looking at with composites, you can see that they've gone through some of those outer rings, those plies. You know, you get that kind of camo-y look.
Is it?
So they are machined and they're relatively straight. So yes, there's the possibility that the top cap doesn't go on to a aftermarket fork. Like, we're obviously going to supply the bike with a fork that it works with. To me, that's way more preferential than going to a truly proprietary system where I've got like a shaped steer. This gives you the opportunity, well, go to the bike shop and measure the steer if you're worried about it. If it's within a few thousandths of an inch, which I'm sorry that I'm going to be talking in imperial this whole time, that's just my native language. I think that's the downside of living so close to the States. It's still a holdover from that. But so that system, if we're comparing it to something that can hit the diameter, I think the fault in analysis of a lot of bike parts is that they're like infinitely rigid bodies, right? Like a steer tube is remarkably flexible, compressible, expandable. And in a typical lower tolerance headset, that thing is under all sorts of weird bending moments and pressure points and stuff like that. And they can put up with it. Those crescent moons are, as you pointed out, a brilliant way of dealing with wide tolerance bands. So one part of it is I don't think the tolerance band is quite as wide as, you know, we're not out by 0.2 of a millimeter anywhere, right, on steer tubes. They're pretty good. The next thing is that the way the system works is it can actually compress quite a bit. Like, I think I told you a cool way of testing it is if you slide that top cap near the top of your fork and put your inner compression plug in there and expand it out, it'll turn into an interference fit right away. Like, you can probably test it without it and just mic it and like torque it, work through a couple torque ranges, and you'll see how much that carbon steer tube expands out. So
just on that point, actually, I've had problems because of that, not being able to preload stem down enough because the compression ring is
locks it in
the
place
inside. And yeah.
So in the same way that your crescent moon that everyone's familiar with can come in, I would actually argue that the steer tube can come out and touch the more rigid aluminum body there. And so
nice way of looking at it. Yeah.
The crescent rings, though, have a whole bunch of downsides that I think are not worth that one pro of I can squeeze them down. Like, your preload on that thing is a function of how much axial preload you're putting on the system, where, you know, you get some guys who want to monkey on their thing, and it like, that's putting a massive strain at like a ring, like with two pointed, even if they've got a nice rad on them, that's putting a really bad line contact band. And for the most part, your compression plug is nowhere near that load to be able to reinforce it, right? That's more for your stem. So that's where I would like spec out like 2 or 3 length. I think I said to you, if you're worried, use one of those really long Shimano inner compression plugs and you hit everything. So what we trade off for is, even if it was sloppy, we're still supporting that steer tube on a massive amount of surface area with full ring coverage, compared to the kind of crescent moon death biters, right? So I would take, So the other thing is that for our system, the top cap and the stem, which is, you know, this is our proprietary system, but it'll work with like an FSA thing. They're pinned together. So those dowel pin holes that are in the top of that, the opposing side, the stem has mating features that pin into that. So when you clamp your stem clamp, those two things are locked together. And a couple of our sort of more, like, we've got some really good Instagram followers, fortunately, people who give like good technical insight. And a few of them notice that where those two dowel pins are located are actually on the flexure side of the stem body. So that'll lock each other into place when you tighten up your stem. There's enough deflection that those two the two dowel pins arc towards one another, and they actually put a moment to lock. So you go from having a concentric thing that your argument is that the stem can move with the steer tube independent of that top cap, but they actually kind of bind into one as you tighten them. So that's another feature that kind of plays to the fact that the steer tube has some compressibility in all sorts of dimensions. So yeah, I think it's a valid concern, certainly from like an on-paper analysis, but I think once you assemble the bike and tighten everything up, the front end rattling is never, like, of the 30 or 40 bikes I've made, that's not yet a piece of feedback I've been given.
Good.
So
we'll test that.
Absolutely. So like I think just to summarize, it's like the steer tube diameters are actually reasonably good. One issue I actually have run into is straightness of the steer tube, because of how accurate our headset is, can induce a bending moment in that top cap if it's banana shaped. Right. So where I've had that be a problem is actually on really small riders, where
shorter head tube,
So the issue there is that you're cutting the steer tube so close to where the taper starts, where the machining doesn't come that close. It's stiffer. That's part of it, but it's also they don't machine right down to that thing. So if you look at your NV fork is really good up top, but if you take it out of the bike and slide that top cap down it,
it's rougher.
You'll feel changes of diameter, and it'll lock up in certain spots. So I know the safety people are going to say, like, you're a total fucking maniac for saying this, but if you did have one that was tight, you can lightly abrade that steer tube with like a piece of 220 and it'll go. So it's there's squishiness in bike stuff. So that's, I think I said to you in the message, that's the biggest challenge I've had, taking sort of the tight tolerance machinist standpoint to something that is really quite sloppy, but in an ease of assembly, like, that's the trade-off there. Like a bike mechanic isn't putting together a precision piece of equipment that takes special alignment tools or a certain amount of care. Like, you want the consumer to kind of be able to. So your other comment was about the jacking feature that I put in there and how that'll lock up if you try to use it. I would say that's an M5 thread that allows you to push that top cap up if the system becomes really kind of stuck in place. I would say that it's there as a backup, not actually as like your first go-to. You just have nothing nice to grab on that, and if you were going to try to use a pair of bearing pullers or something, you're going to screw up the outside of it and you're going to be pissed off. So it's the way I typically disassemble a bike is I push the fork down until the steer is flush with the top of that top cap, and then it's, logically it doesn't make sense, but you can then use the fork pushing back up to kind of just wiggle that top cap up and out and then pull it clean off the
So like you said, the way I did it was, instead of using it with a bolt in there to push down, I actually just, like you said, put a bolt in there and then lift it up on the bolt and wiggle it out. So with a bit of grease, it would have come out easier as well. But and let's not forget the original A headset invention, with the compression ring, or the crescent moon, as John's very romantically called it, was invented when we had all metal steerers on forks. This is before carbon steerers were a thing. And obviously those metal steerers, I don't know if they're like shot peened or they have some sort of very hard surface finish on them. They're kind of rough. I don't know if they're peened or it's just part of the manufacturing process, but you don't get the ring of death from the compression ring on a metal steerer tube. Like, you never see that on a mountain bike. You maybe see some sort of polishing or fretting, but really structurally it's not going to affect it. It might even give you a bit of work hardening in that area. But on carbon, the ring of death and that such small line contact is where we see all the failures. That's where the failures occur in carbon steerer tubes. And it's a kind of you're damned if you do and you're damned if you don't with the preload, because if you really wrench down on the preload to take out any slop, you just increase that pinching load on the steerer tube. And if you don't do enough preload, you get rattling, and that's also going to give you the ring of death. So the A headset system with compression ring isn't great for carbon steerers, and unless you've got a very kind of deep one with a nice big face contact, they're not great. And then I know that at one point, about 10 years ago, Cannondale started to make a plastic compression ring to be kinder to the steerer tube, and they rounded that from, I think there's FSA who made that for them for 3 or 4 years. But then, okay, it's softer on the carbon, but under load, that plastic creeps So after 6-8 weeks, you've lost a little bit of headset freeload. You need to tighten it every 6 weeks because the plastic's creeping. And I've seen that with Acros headsets as well. So this is a refreshing take on the headset system. But yeah, we'll see how that goes. Moving on to the elephant in the room. Sorry, we just got to clear this up because there's so many comments on the last video. Let's talk about galvanic corrosion. Why is this bike not going to snap on me in 2 or 3 years' time after it's got all salty?
Yeah, well, I think that's a carryover from the early transition from lugged alloy frames to carbon, where they basically took an alloy frame with, I'm assuming based on the time, I wasn't around back then, that they would have been cast lugs, like investment casting, and they plug carbon tubes into them that are an equivalent diameter. So I think galvanic corrosion is an absolute concern. That we do a lot to kind of deal with that, and we'll get into it in more detail. But I don't think that the only mechanism that those bikes failed by was galvanic corrosion. I think there are all sorts of other ways a bond can fail, and a lot of it might have come down to the technology just not being there 20 years ago. And people, there will be the commenters that say, you know, the bike industry learned from their lessons and they moved on to fully carbon bikes. But I think that wasn't necessarily done because it was a better system. It's done because it's a more profitable system. Like once you have your mold set up and you're yeah, and it's a damn good way to make a bike. Like an all carbon bike from a high end manufacturer these days is a pretty good piece of manufacturing. But we can get into like why I didn't choose to do it that way in more detail later. But so the galvanic corrosion thing is, you know, most of your followers are going to know this already. But when you have metals that have or materials that have a dissimilar galvanic potential in either direct contact with one another or in an electrolyte solution near one another. So aluminum and carbon fiber, like I think it's important right now to draw the distinction between carbon fiber and a carbon fiber reinforced polymer, which is actually what most people say when they mean that when they say carbon fiber, but like carbon fiber is the loose strands. Carbon fiber polymer is what your bike's actually made out of. So we use aluminum and carbon, which is everyone goes, oh my God, throw their hands up. That's just gonna, turn into a battery. It's gonna disintegrate right away, whatever. So we take multiple steps. I'd say it's kind of like a belt and suspenders approach none of our parts are raw aluminum. We began with nickel plating and now we've moved to anodizing. So anodizing is actually completely electrically inert. It's like kind of like a sand or a glass, right? It's an aluminum oxide layer on the outside. So if you touch the bike on the lugs with the multimeter, you're not going to get any continuity. So that's like step one. The aluminum is protected. The joint itself, the carbon fiber tube, the carbon fiber polymer tube actually never touches the aluminum anywhere. And this is kind of like, it's hard for some people to visualize if they haven't seen the assembly process. But when we machine the lugs, they're slightly oversized. There's a radial gap that's equivalent to about a sheet of paper, 2 sheets of paper. That's what we fill with the bonding adhesive. And the bonding adhesive has glass beads in it that are a diameter that's equivalent to that radial gap. So when we're putting the tube into the joint, it's kind of like a linear ball bearing. The tube is actually rolling on these glass beads and it's never touching the aluminum anywhere. So we don't actually have an electrical circuit anywhere on the bike in terms of continuity. Then the next kind of thing is that the carbon fiber, for the most part, the actual carbon fibers aren't exposed. They're inside of plastic, which is an insulator. Like your electrical wires in your house they're covered in plastic and they're not zapping you, right? So that's like another protection layer. So there's the aluminum's insulated. The actual bond itself is an insulator. Like most of these structural adhesives, if you look at the technical data sheet, they're giving you the electrical dielectric coefficient, right? They're insulators. Yeah. So the glue on its own would protect it. Like my original bike, the one it's like 3 or 4 years old now, it's raw 7075 and off the shelf Rockwest tubings that I didn't do anything to other than just bond them in with the adhesive.
Right.
And if I put a multimeter on a lug, I can like probe it and it'll give me a contact. If I go to the lug like head tube seat cluster, there's nothing. It's dead because those parts aren't actually touching. So then there will be the people who say, yeah, but if I sweat on it, that's going to bridge. That's going to bridge, and that electrolyte presence is going to be. You can't tell me it's not going to get into the joint. All these things, like the joints are potted in a sense that there will be situations where I'm sure moisture can wick its way in there, but it's going to be on either side of that adhesive. and maybe there's a pocket in there where it can touch, but then what it's touching is plastic on the carbon tube and anodizing on the actual lug. So it's impossible for me to say that, galvanic corrosion can't occur. That's just not, I'm not comfortable saying that. I think that the likelihood of it occurring is remotely rare. We've done a lot of submerged testing where I make like a fully saturated salt brine and I glue up lugs and stuff unprotected, throw them in there and just watch. And it's actually it is kind of remarkable that on some of them, ones where I just use the cut end of the tube is facing out into the electrolyte solution. I have unplated lug. It'll corrode somewhere 6 inches away from the joint. In a perfect, but no one's sweating that bad. If you're riding your bike in the ocean for extended periods of time. So a lot of the failure mechanisms on those testing were actually because the carbon itself was in there for so long that it got waterlogged. And that's, again, because it's got that cut end face where the capillary action can kind of pull some water up into the tube. But it's, again, on a bike where it's fully sealed at either end. And we get into the details of how I prep the paint joint, paint the tube, seal them, and get them in there. But yeah, so I think I would say that it's I'm going to take a stance in the YouTube comments that I'm only ever going to drive a Cybertruck or a DeLorean because metal body panels can corrode. That's well, okay, people are going to look at you and say, well, yeah, but you paint it. Yeah. And it's not going to corrode. It's important to know that there's a failure mechanism, but also that there are solutions available to engineer around it. So people will ask, why not use titanium? That's way closer. It's not removing the galvanic potential. It's reducing it. But there are a whole bunch of manufacturing trade-offs with machining billet titanium bike. That's that's going to be a $50,000-$60,000 bike. To machine those from machining aluminum is a remarkably good material. The high strength aerospace stuff, aerospace. Its strength to weight ratio is really good. It's 70-75 also just doesn't turn into rust if you leave it out exposed, right? It's not corrosion resistance is not one of its noteworthy characteristics, but that doesn't mean that it's
6,000.
No, or there's
relatively speaking, still very good.
It's not total shit, right? That's that's a
not
thing.
Not the best aluminium, but one of the best materials.
Yeah, so it's and then the processing cost of it too. I can machine that practically, where to machine those really complicated thin wall structures out of titanium. First of all, the billet of titanium is going to cost more than my bikes do currently. Finished. The machining time is through the roof. Your end mill consumption is through the roof. Your process reliability.
Hard on the machines.
Yeah. So, I could switch the material to remove that problem, but it's I've done all these other things to make it not a problem, and then that final kind of trade-off to switch to a way more expensive material just isn't worth it in the final product. And it's worth saying that we offer a lifetime warranty on the bikes to the original owners. I know that there's going to be the trolls saying but you're going to get hit by lightning tomorrow, and then what good is my warranty? That's just a fact of life.
Those people aren't interested in buying bikes, man. Trust me. Just had a thought. For people still worried about galvanic corrosion, everyone's fork has an aluminium thread bonded into it to hold the front wheel on. So there you go. That sort of clears that one up, I guess.
Brake mounts, your bearings that are sitting in your carbon frame. That's a galvanic potential. Most frames have a bunch of aluminum bonded into them.
If it's not prepared and cleaned and primed or whatever, it will go wrong. But it's not. It's out there anyway.
It might be between your legs.
Good point, Ashley. If you want to see more about John's work day to day, John's Instagram feed is a daily ritual for me, just to check out the machining porn. So if you're into that kind of thing, go follow Framework on Instagram, and you'll see way more stuff day to day than we can pack into this video. But just a quick note about the galvanic corrosion thing. I think, like you said, anodically or whatever, anodizing something after it's been anodized, it's virtually non-conductive if you were to probe it with a multimeter. I think people out there throw around the word galvanic corrosion without actually realizing what it is, because I think if people take the handlebar tape off of an aluminium bar after a couple of summers riding in the tropics, they'll see it's gone crusty white and the aluminium is dissolving, and they think that's galvanic corrosion. that's just corrosion from sweat. Like sweat and salt water still corrodes aluminium if it's anodized or not, and that's what that white crusty stuff is. Because you get that from running on the servo trainer, you'll get that all over the bike, and I think we need to be very careful about if something's anodized in a really extreme environment like high humidity or salty in the tropics, it will still corrode. And we've seen that with the Shimano cranks. I think a lot of those failures was maybe not galvanic corrosion, but stress corrosion cracking from salt and moisture, and that's still going to happen with certain aluminiums that have been anodized. So it's not a foolproof system, but what steps can you do to mitigate it so it's not your most likely failure mode? That's what I would say. And personally, in my last job where I was bonding robotic arms with very similar to aluminium plugs into carbon tubes, mandrel wrapped carbon tubes where the diameters are very well controlled, and we were using filler beads just like you to space the bond line thickness to, I think the 3M glue I was using specified bond line thickness between 100 and 200 microns. So you like
that's
you said,
pretty big.
you can buy the filler beads to actually know that your plug is in the middle radially of your tube.
Yep.
What I found, and I know this is another critical question I've got of your process, is if you've taken on the anodizing in-house now, right? What we found in the testing is that the anodizing, and particularly the color and the supplier of anodizing, would vastly affect the bond strength. Yep. To some extent, where we were doing destructive testing of these tubes, sometimes the bond would just like adhesively fail throughout the bulk of the, not throughout the bulk of the material, sorry, it would like the bond would just break down. Sometimes the bond to the anodizing was so good it would almost like pull the anodizing off the substrate, like the aluminium. It would basically just rip the surface off of the aluminium, and like that was a kind of a good test because it was way above the design load, but it would be so strong to the anodizing it would pull it off. And then some anodizing colors, it would just have a terrible bond. So how
were those coming from different vendors? The colors?
It was coming from the same supplier, but where they got their colors from, we had no trace of it. So how do you test? You also you're allowing people now to spec the color of the anodizing. Yep. Do you test the bond strength for every color? Because I've personally found that as a big factor. And when we were looking at either bonding to a raw aluminium coupon for testing versus an anodized one, there's very little literature on anodizing and how it affects bond strength because there's so much variability in anodizing. Are you testing every color?
Well, this might be a good segue to say that I've told you to not ride that bike I sent you, and we take safety really seriously, and I'm running a bunch of tests right now on adhesives and the anodizing process to try to ensure that potentially that issue you just raised could be going on. So I do need to test for that. So we're switching our process right now to be we'll do test coupons that follow every bike through material-wise. So like when we machine some of the lugs, we've got blocks of aluminum that are kind of left over from what we cut them out of. So those will get sliced up and follow the frame through its entire manufacturing process, including anodizing and bonding at the same time under the same conditions. So I've got some on my desk here. These are just samples out of like flat bar. So we've got, I can do a lap joint on these. These are just raw, but lap joint and then test them destructively. So I think that's a very valid point. But one of the main reasons we are doing the anodizing in-house is that we can guarantee the control of the parameters that go into it. So the reason I didn't initially start with anodizing and I went with the electroless nickel plating is in order to do some of the features we have on the bike, like where the bearings go in the frame, I need to guarantee a really high dimensional accuracy on whatever the surface finish is process. So the local anodizing vendors, they're just going to throw your shit in with whoever else's stuff is there at the same time. And they're going to give you a tolerance band on the thickness that's, in terms of a bearing fit, it's wider than my total band is on the bearing fit. So what we have to do when machining the parts and anodizing them is I actually machine them oversize because the anodizing does add a bit of thickness. So we need to take that into account to ensure that the bearings go in there properly. So I didn't go with anodizing. Like the nickel plating is something that we've used on injector molds. It's like a process that we're familiar with there, and they can guarantee me 4/10 buildup every single time. So dimensionally, it was really good. That vendor has had some other problems, which has made us want to bring things in-house. kind of QC issues like you're talking about, you never know what happens, right? They tell you, we've done this, we did the same thing we did last time, but you don't know if the guy took a smoke break for 20 minutes too long and left something in one of the tanks, right? Like these, finishing is one of the most challenging parts of any machine shop's like surface treatments, because I've got all my value in that product basically at the end, right? Like when I take that thing off the machine, I've put all the value of the material into it, all the value of my machine time, and I'm sending it away to someone who's going to charge me $50 to anodize it, and they don't really care enough to ensure a really good job. So I think that your question is super valid, and it's something that we're running tests on right now. So yeah, it's like everything needs to get, if we want to introduce a new color, maybe the reason I asked about where the color's coming from other vendors, not necessarily on the die, but just other anodizing shops, is like maybe the baths they do for that batch was different. Your stuff was in with other parts. You're seeing, you're associating it with color. That might be actually like a confusing kind of variable when it's something else occurred that, you know, they were running that dye bath at a different temperature, whatever. So yeah, I think that is something that we are currently testing right now, and I've got kind of like a hold on production until I carry out a whole bunch of destructive testing. I've got frames in the ISO tester right now, testing different adhesives as well. The problem with your bike, or like my reservations with having you ride it, is it could be that, it could be a particular Loctite product that we've been dealing with that had like recalls for a year. They've told me that it's all good, but the vendor we bought it from was not necessarily forthcoming with that. So
really,
yeah, it's I'd say it doesn't look good that I've sent you a bike for review, and I'm saying probably I'm just going to send you another one for peace of mind. For all the haters in the comments that are saying, oh yeah, that thing's going to fall apart. Well, here the guy's admitting it's going to fall apart. What an idiot. So yeah, I guess I'll cross that feedback when we get there. But yeah, so I think that's a really good point. And yeah, so you've got carbon fiber and aluminum, but there's like a lot of shit going on in between those two things, right? So I've got the anodized layer, then the adhesive, then epoxy, then carbon fiber, and those type of failures you're talking about, where like basically the from a bond strength validation, you want the anodizing to peel off. That means the bond wasn't the weak link, right?
Exactly.
But then you need to control, like when you're taking stuff to destructive failure. So I've got like frames around the shop right now that I've taken these test coupons, raw aluminum, and just like any flat surface that I can bond one of these things to, I'm bonding it on there and then like doing a peel test and seeing like what breaks does the so anodizing is like a pretty widely used in the aerospace industry as a bond prep mechanism, particularly phosphoric anodizing, which we're using sulfuric acid. But like I think there was one comment on your YouTube video where people was like, oh yeah, great, bonding to aluminum, like a super slippery, like super hard, super slippery surface. It's like if you look at anodizing under a microscope, it's like super porous. It really wants to. Like that's what takes the dye. It's like a honeycomb structure that the dye goes into. So like we need to validate the dyes. We need to validate the sealing. So it's not just anodizing, right? It's like we anodize, and then there's a very particular sealing process that goes into giving the product both like UV stability, but also like remarkably better corrosion protection than just anodize. Like if you just anodize and leave that cell structure open, so we're experimenting with like cold sealing and hot sealing, and each of these products have like fluoride and nickel in them that basically plugs the top layer of the anodizing so that stuff can't get into it. I think that's a really, really valid question, and unfortunately, the answer I don't have right now is, I know it's a problem. We've tested for it. I'm currently testing those things. That's why there's been such a long lag from. I really haven't put out many bikes since we stopped the nickel, and I've been fighting with. Fighting's maybe the wrong word, but like working through all those little steps along the way of, how tight does the temperature control have to be on each of the baths, like chemical concentration, how often do I need to switch them over, and then developing a system where proactively it's like you don't even let the bath get close to that threshold. It's like once every month I change it, or once every 10 bikes. So so for me the big lesson is test the adhesives when they come in, because even if like we buy some of them from aerospace vendors and they're tracking lot numbers and they're on top of it, but because they're so anal, sometimes there can be long delays. So we buy the same product from other vendors, and they don't have the same, like who knows what their warehousing looks like. Well, they don't care to follow up if something's wrong. So I've had to do that proactively, but Henkel won't talk to you as a small time. Like, you need to go, yeah. So, but the other thing is like temperature control on how they're stored and how they're transported to you. Like, I'm in Canada and most of the stuff is flown into us. So when it's in the bottom of the airplane, did it go below temp? Did it go over temp on the tarmac while it's waiting to get unloaded? So it's like, now the workflow is the adhesive comes in, validated on a test coupon on its own. Then run the test coupons through the manufacturing process, just so I have peace of mind. So I'm not calling you and saying, don't use that bike. I can say, oh, hey, before I even shipped it out, I tested this and it hit our criteria. And then I'm still going to keep one on the shelf for our records, just so if you, in a whatever amount of time, say, hey, I'm having this problem, obviously that won't have been subjected to the same load and environmental conditions that yours has, but it's still better than nothing, I think.
So yeah, just going back a little bit in that point, you mentioned ISO testing. Now I know you've got your ISO testing, or at least your frontal load cyclic testing in house, where you basically got the fully reversed cycle on the front fork. My problem with custom bikes, whether it's steel, titanium, whatever, is that you don't like. Let's just from my limited time walking around Chinese bike factories. They've got a bike of every size that's come out of every mold, painted white so the cracks show up. And they've got these rigs lined up for every size of each frame design. So with custom bikes, you can't do that because you can't take the customer's bike and test it to destruction.
Yep.
So how do you validate a custom bike? Because you can't ISO test every single frame.
Yeah, I mean, that's in a way maybe a dirty secret of independent frame builders. You can't. You can take your best guess at what does the weakest bike I'll ever make look like and test that. So it's a combination of smallest and largest frame, and then for me, the kind of most spindly tubes we'll ever put in it. Okay. The question beyond that is like, is ISO testing a valid, like, does someone who weighs 90 pounds need a frame that passes ISO testing if they're riding a couple 100 kilometers a year? It's a thing that I think is really important to learn about how your frame handles the loads, and like we often push them to destruction anyways to see like where is the problem. But it's not like the most like it's a test. I don't think it's the definitive good or bad. That I'm not saying I'm shipping out bikes that are like nowhere near passing it. It's just that it doesn't cover. There are people who say ISO testing's not nearly strict enough for a downhill mountain bike, for example. I think there's test labs in like Germany that have their own standards. They say like this is
ESP, I think, or someone like that.
Yeah. So it goes both ways, right? It's like there are a lot of riders for whom a frame that passes ISO testing is overkill. And when you're getting into really boutique alloy frame builders, some of them might say like, I'm not comfortable with this frame being ridden by someone over a certain weight. And that kind of has to be their judgment call based on their experience. So yeah, our way of dealing with it is whenever I'm validating, I'm using kind of like the worst case scenario in the carbon tubes in terms of the smallest wall thickness, the most flexible. And really the thing that will often break on our tubes is that transition point, like in the joint. Where those loads change between the lugs. Like the frame I have on there right now, the lugs have gone through almost 300,000 cycles. And I'm just machining the tubes out of them and bonding new ones into testing.
You're recycling the lugs, yeah.
Well, like I don't have unlimited budget and it takes time to make them. So it's like right now I'm not validating that necessarily for ISO. I'm learning about what can I get away with on the tubes and still have them pass. So yeah, it's your point of the only way to know for sure is to destructively test absolutely everything you make, like make a duplicate of every bike essentially. So my cost for sending you a bike is now double because you want to. But that's
more
I think
than
just
double probably because it's not. Yeah, it's the time, isn't it, of running the test.
And I would say though that you talk about the facility that's got all the bikes lined up, and I know that the better ones do some amount of statistic sampling out of the production line to keep doing that. But the manufacturer of a molded carbon bike has so many things that can go wrong that will cause a frame to fail ISO testing that still gets shipped out to customers, right? It's like just because you tested everything. I mean, you tested that one bike. So in aerospace manufacturing, like you're validating a product But you're validating the process that made that product, and you can't change a single goddamn thing about it once it's signed off. And that guarantee of every single little step being nailed perfectly is why I didn't want to go to a carbon fiber bike where you're talking about like upwards of 700 pieces of carbon being hand laid in there. Yeah. Like, you can't get each one of those in the perfect spot. There are going to be manufacturing deviances, and now does that mean the bike's going to fall apart? Probably not. Like, you need to get a lot of things wrong, but so it's like the two questions I get all the time from like young people, young engineers interested in biking are about like ISO testing. How do you design a bike for ISO testing? And the unsatisfying answer is it's a guess and check kind of system, right? You just like, you take your best guess, you throw it in the machine, and like that's where like the whole ride tuning and like trying to get the layups just right so the bike feels good but still passes. It's like they start somewhere, but then it's just add a bit of extra carbon, remove some carbon, throw it in.
From my experience, that's what they do. You know, that if they've got the same, if they're developing a new model in a, you know, from a Western brand in an Asian factory, it's kind of naive, but the Western brand goes in with two things. They go in with a weight target and a stiffness target, and everything else is and the 3D shape, which an industrial designer has drawn. And then it's basically a fight between the guys in the factory saying, well, we need to add a bit more carbon here because you want it drops these days, and the small parts of the ISO test, but the large is cracking. So they just keep adding swatches of carbon. They redo the test, and they just keep adding swatches until it breaks, until it stops breaking. And it's like that test might pass that test, but that's not the test of actually riding the bike. That's not what happens in real life. And you can't really design an ISO test rig to simulate every load that you get at the same time.
Yeah, I think that's a really valid point too, is that it's a very defined load on the bike. It's, again, we do it. I'm doing it because I think it's valid, but so what I didn't say before is the two things that people always ask me are like ISO testing and FEA. What do you do? FEA. It's like, well, man,
there was a comment on the video about FEA, wasn't it?
It's so complicated. Yeah, let's take a monocoque. I'm using air quotes there. They aren't like a carbon frame, a molded carbon frame. To do the amount of modeling it would take to do your layup schedule for one of those bikes and accurately simulate a composite structure is like no one does that. They're throwing in some like, you know, base assumption of how the material handles like kind of isotropically, and they go from there. It's a tool, just like the ISO testing is a tool. It's a very useful tool, but it has some serious limitations. Like, I can't be an indie frame builder who says, or I could be, but you know, Alex, your question about ISO testing, I take the two ends of the spectrum. I know what the FEA results for those models look like. I pass them physically, and then as long as my FEA for any other frame matches the results, I'm good to go. It's like some people will say that, and I don't think it works that simply. So it's like, as long as I don't hit a peak strain anywhere in my, you know, FEA, and I've changed the design, we're good to go. So the other big comment was about weight. Our frames are not going to be the lightest weight frames. I'm not making a 600 gram frame. Like, yours is probably 1,200, 1,300 grams for the frame only.
Which is, in my size, not ridiculously heavy. Like,
no, it's not.
You know, a molded carbon frame was probably a light one in my size is probably 1,000, 1,100.
And then,
not that I care. I do not care about weight. It's such a meaningless thing in bike performance. Yeah, it's an uneducated topic, right? Honestly.
I am of that inclination. I think like the system weight on the finished bikes come out quite competitively. There's a couple other things, like you're not putting a bottom bracket in it, so save whatever, a couple grams there. But the lugs themselves, to your ISO testing, are kind of overbuilt. And this will kind of circle back to some of the design choices of like the ride characteristics of a bike come from the tubes, not the lugs. All your flex is there. So that's what I need to be able to have control over for ride characteristics. But I kind of treat each of the nodes on the bike as like a rigid body. And they kind of are compared to the carbon.
Yeah.
So that frame has been totally beat to shit. And the lugs are just nothing. They're essentially inert. What'll happen is the tube will break just beyond them, or it'll start to snap buckle inside there if I go too thin. So that's where it's like your comment about local reinforcement is, if I want to have a tube for a really light rider on a really comfortable bike, it needs to bend a lot in the middle. But that means that the relative angle between your lugs is changing a lot. And that's putting a high load right at the the joint. So those are the type of things that we need to validate in terms of me having the confidence to say, if I made that bike a little longer for a slightly bigger rider, is that thing going to now spontaneously combust when someone rides it? Like, probably not. So yeah, there's no, the person who needs to know that every single frame is 100% ISO tested and validated should not be buying bikes from
any custom bike.
No custom bike. And to that, I would say, just because the mass-produced ones doesn't mean the one that's between your legs. Like, how many people know either firsthand they've had a bike that's gone back for a warranty, a crack somewhere develops in it, or a direct friend who's had that happen, right? It's not like, it's not infallible. Mass production is not infallible to variation, even though the testing was carried out. And, you'll hear stories of, like, guys who deal with the Far East. If it's right after Chinese New Year, don't pass any of those frames, because no one gives a shit in the factory right then. It's like so when you're trying to get something through production, you kind of not necessarily cherry pick, but it's like, maybe someone came off a bender and they're not really paying attention in the layup room or whatever it might be, right? It's like,
or before Chinese New Year, when there was just a rush to get the shipment. It reminds me of when I think I showed you the pictures when I was at university. I built a bamboo frame out of bamboo tubes, and I used lugs like yours, but instead of external lugs, they were internal lugs, so you couldn't actually see them. So it looked very bamboo-y. But those lugs were not. Well, I'll put some pictures on the screen when I edit this. But those lugs were not breaking. They were almost just rigid bodies in the simulation, if you like. And it's nice to be able to do that, because I think if you make a monocoque bike or a bike in a carbon mold, quite often those joins at what would be lugs if it was a custom bike are where you get issues with layup compaction, voids.
It's the hardest part of the bike.
Cracking. Yeah. But if you do a lugged compaction, you can almost overbuild those in a way that you narrow down the failure areas just to the tube, or at least the transition between the tube and the lug. And you're safe in the knowledge that actually the lug is the solid part. You don't need to worry about that. So it kind of reduces the areas that you need to really validate, I guess. And the thing I've seen with the modern frames is that if you take a compact double diamond shape, like traditional sloping top tube bike, like something like an original giant TCR, where all the loads in the tubes, like a truss structure, meet at the nodes, whether you consider them pinned or rigid. And then you look at modern bike design, which is more towards this drop seat stay design. And you're taking that common node at the top of the seat cluster and you're moving it down. And the problems that's caused in validation of bikes and cracking on these ISO tests is crazy. And that's all driven by like marketing hype that those bikes are more comfortable or they're more aerodynamic. But the problems that design has caused in that kind of manufacturer is telling.
I don't think it's insurmountable.
Lots of warranty issues there. You see lots of warranty issues there.
You're asking that seat post to do a lot of work, but composites are really good at that if you get it right. To get flexibility. Like, so some of the big design choices that we made with the bikes, we're kind of haven't even gotten to them yet. But yeah, the kind of confidence in the lugs being milled from aluminum and all the complexity of the geometry occurs there, and that's handled by a CNC machine, not a human. It's like I'm removing, like, no carbon frame builder is going to tell you that the tubes are the hard part. Like you just mentioned it. All the shit happens where you're transitioning loads through weird geometry areas that are hard to consolidate, hard to lay up accurately. But when done right, that's truly the best way to do it. In my opinion, carbon fiber is like, if I was making static designs, I would have a hard time not using that process, other than all the challenges that come along with actually manufacturing the bike on a day-to-day basis. So yeah, the way I make the tubes is not with a human, right? Like I'm using a CNC winding machine that can be highly repeatable, programmable, and that I can just basically say, okay, Alex's tube is going to have this. I'm going to run this program to create this tube, and it's gonna. I'm not asking someone to read through a manual of like flip to the next page, and put it down, and like, so we can tune the ride feel in those tubes, but knowing that each of those locations where the tubes meet one another are kind of dealt with in a manner that looks reasonably good. I know aesthetics in the bike world are, it's not something I designed for. Really, the way the bikes look are a direct result of how they're made. But yeah, like that, any bike manufacturing process, the challenge is in the joints. I don't care which way you do it. It's
Yeah.
so I'm trying to remove that off of a skilled human, whether on a tube-to-tube carbon bike. That's, you're still manually coping, you're overwrapping. So that's how some custom carbon builders do it. Even production bikes are still, some of them are done that way. Or any alloy frame where you're cutting, fitting, tack welding, brazing, whatever it might be. All of that takes work and skill and is a possibility for things to go wrong, where the CNC machine takes it out of a block of material. It doesn't care if your head tube is like nearly twice the length of my head tube. The CNC programming is all automated, and it'll do that without any fuss.
I mean, one of the this goes back to the headset thing. I think why the bike industry is stuck with the A headset and compression ring design for so long is because in the current production method, where they in-mold the headset seats into a big clamshell mold which weighs 80 kilos per half, that's the only way they can do it, and those headset seats will come out slightly off. It's just, that's how it is, and then the compression ring takes all that out, and that's probably one of the hardest parts surely to mold into a bike frame is the carbon compression molded headset races, or the headset seats that go into those. But like you said with yours, you're all down to basically the tolerance of the machine, which is orders of magnitude higher than it can be when you're molding it by hand. But talking about the tubes again, you, just to remind the viewers and the listeners that John actually makes those wound tubes in-house on an in-house made machine with your programs designed into it, which I think is pretty damn impressive. But one, just to be critical again, I remember months ago I said to you, hang on, you're winding every single tube. There's no 0-degree fibers in these tubes. They're not going to be very longitudinally or in a flexural sense very stiff, which in areas of the bike is desirable. You want it to have a whippy, bendy tube. But if you look at the layout schedule for a S-Works or a Giant TCR, you've probably got 40-50% of the plies are in 0 degrees, which makes them so stiff, which is a desirable ride trait. Is it? We don't know. Is it some sort of placebo effect, or is it marketing? I don't know if a stiff bike is a good one. There's some magic figure out there of newtons per millimeter, but it'll
be different for every rider.
You can tune the stiffness, like you said, through the program. But I think in my frame, did you manually add some 0-degree fibers in some of the frame?
Yeah, at the joints, and so that's again as I'm testing the anodizing, going through tweaking, like how thin can I make a tube in the center section. Right. With local reinforcement at the joints and get away with it, because
basically butting the tubes in an old-fashioned sense.
Yeah. For lack of a better term, the wall thickness will change, the layup schedule will change. So yeah, we do some shallow angle passes which are about 20 degrees. So that's, I think, on the length of your down tube, you might get like one revolution by the time you're at the other end of the tube.
Okay.
So that's the major advantage of filament winding is for a round tube is that you can make structures that are very torsionally stiff. And I think in your down tube, that's where a lot of the power transfer comes from. It doesn't matter too much if it's like bending. It's like when you load up your bars, you're pulling up and you're trying to torque the down tube.
Is it?
You're putting a torque moment on it, more than like a in-axis bending, I think.
Yeah.
Because you've got the top tube kind of helping you from it wanting to bend. And so part of the recent change to doing shape tubing, which you have that bike, that was another one of the delays, is changing the tube shape in between getting that design finalized for you, is playing with second moment of area. Like I started with all round tubes. When I did my original bike, it's because that's what you can buy off the shelf, and they're like, probably 1.5, 2 mil wall thickness, same layup schedule all the way down. They've got really no anisotropic behavior in them, because they're just, they're meant to mimic like what you might get from a steel pipe. So we can change both the properties of the tube, but also the shape of it. And shape, like a bunch of your videos go into detail on second moment of area. That's where you can get kind of differential riding characteristics in plane and out of plane. So that's been a really important thing in terms of getting power transfer, a bike that still like feels stiff, but is actually super comfortable to ride. Like you don't feel road noise the same way, because it can kind of bend in your forward motion. So within the layup, we can tune like our seat stays, for example, are super flexible. They're designed to be durable. There's quite a lot of carbon in there because like the spindly little seat stays, I don't want them cracking. But if you grab the your two seat stays with your hand, you'll be able to like pinch them towards one another
Yeah.
quite a large
Yeah.
amount. And that has that layup has way more kind of hoop in it, like
Okay.
shallow angle passes. So that has really, at either end, that has really good compressibility in the joint. You're not going to crush it
Yeah.
down and have it
Yeah.
buckle. The weight is there, but you have a tube that can bend quite a lot, and that's
It is.
going up to your seat where you can get some flexibility. So
It is.
your comment about like a ton of UD, like if you can make a frame that passes ISO testing with a remarkably small amount of unidirectional carbon fiber everywhere. But
Yeah.
if you like stick your thumb into the top tube before it and oil
Crack.
can that,
Yeah.
it's going to crack there. It's like,
Yeah.
so UD fiber is really good at transmitting loads in plane.
Yep.
And it's really bad in torsion,
Is it?
right? Like it's like the analogy I always give people is grab a pack of dry spaghetti and twist the two ends. You know, they're just going to spin.
Very good analogy,
but
that.
If
Bend
you
it
take your
and-
hand,
yeah.
yeah, it's stiff. So that's UD fiber. So the
It
other
is.
thing that we can do is if you want to build in some durability, I can add some hoop passes at a very shallow, like a big step over. So it looks like a pair of fishnet stockings when it's laid up. It's not a full coverage.
Is this-
But that's going to locally reinforce your more axial passes where you can't pinch that tube. So you've got durability, very minor weight penalty, but it's still going to bend the same way axially. Because I haven't added, like, if I did like a really shallow angle pass, I'm basically making a giant
Yeah.
spring. It can
Yeah.
compress axially a bit. So those are all things we can play with on the winder. And then moving to molding like we've always molded the tubes, but going to shape tubes for the top tube, which is pretty extreme compared to the down tube, but also the chain stays. Those are all things where we can play with putting fiber in certain places, automated by the winder. And then, yeah, we'll like, there'll be instances where like I'll say I'll cheat and on either end of the tube, put some fabric before I wrap it, like on the mandrel on the machine. So that will help me get localized.
Oh, okay.
Yeah. So there's no like end-to-end 0 degree fiber in the bike, but there's some pretty shallow angle stuff. So your tube would have probably 4 main layers of, I say probably, it does have 4 main layers in your down tube, where a lighter rider, I might go to 3.
Okay.
Shorter, lighter rider. You know, it's hard to make bikes for really tall people and really small people.
Right.
It's really hard to make it stiff enough at your size, just because the loads are, you can bend a long tube way more easily, and it's really hard to make a comfortable bike at a small size because the triangle is so compact.
So you're wrapping these tubes on your programmed CNC wrapper,
Yep.
And you're at the same time you're impregnating them with the resin. So
Yes.
it's not some factory workers there with a paintbrush slapping on resin afterwards, and then you're pressurizing them in house in your own molds, which are CNC'd by yourself. And then you vacuum bag, or you have to do you. I know at some point you're working on like a latex former for latex.
Yeah. So the
bladders.
bladders.
Yeah.
So the workflow is, we start with dry fiber, which in filament winding it's called wet winding. So you're adding resin, you're slopping resin somewhere along the way, or you can filament wind pre-preg toe. So that's actually what we started with. There are pros and cons of working with pre-preg, and I think the cons are not worth the pros in my setting. You're limited to your fiber and resin choices when you're buying pre-preg. You're paying a high premium for it. It has really strict handling characteristics, especially if you care about moisture ingress in a humid setting. And the processing temperatures are quite high, which has a whole host of problems in molding. Your comment earlier about the headset bearings. Most molds are steel. Carbon fiber and steel have a different coefficient of thermal expansion. And really high-end aerospace stuff we've worked on, the tooling's made from carbon fiber.
Carbon fiber, yeah, molds, yeah. Same in F1.
So at room temperature, your dimension is what it is, and they all they all kind of work out. So like your thermal, and they're cycling those molds so fast, right? Their productivity is strictly tied to how many times they can get that mold in and out of the press, and that thermal profile is really hard on the resins. There are snap cure systems that are developed to deal with that, but if you're dealing with aerospace composites, the cure time is like days. They want to ramp hold, and to get
very slow.
Yeah. So we wet wind because I can just store dry fiber on the shelf. It doesn't have buying composites as a small person. I actually order stuff from Easy Composites.
Oh yeah, yeah,
Yeah, like which is local-ish to you, right? It's
yeah, very local.
So I think my minimum order quantity on the Mitsubishi prepreg I was looking at getting was like 40,000 Canadian dollars to order it, and it goes bad in a year.
Wow.
Again, because it's aerospace, like you could use it, but like as long as it's stored in the freezer. But yeah, then it's like each day you got to take it out of the freezer, let it come to temperature without getting any condensation on it. Do your winding, put it back in the freezer without getting moisture in there. It's just like, yeah. And then the curing cycle is bad, and the mechanical performance is just whatever you're going to get from that resin system. So the resin we use is, it's not proprietary, but the company we buy it from has like mixed various aspects of their different product lines. So it's really sounds pretty gimmicky. It's a core shell nanoparticle toughened resin system. So it's remarkably fatigue and like it mitigates cracks like crazy. Right. So in the resin, there's these tiny little nano-sized beads that have a hard shell and like a rubbery core. No, I got that wrong. It's a hard shell and a rubbery core, so that when they can kind of flex a bit with the matrix, and like if a crack comes in and it bumps into that rubbery thing, it just kind of stops. It's almost like a nodular cast iron where it like. So the tubes are strong as hell.
Okay.
Yeah, the machine starts with the dry fiber up on the spool, and it's passing it under a digital dosing system. So most big wet wound structures are like the fiber dives into a bath, comes up and out, and they have what's called like a doctoring blade, basically a squeegee to take off the extra resin, right? And then it's deposited onto the mandrel and whatever your layup schedule is. The issue with that is it's really hard not to get entrained gases in that. Like you want like beautifully laminar flow coming off, and like you just can't not work air into it. So my system, I mix the resin and it goes into what's essentially a digital caulking gun, right? I have a small ball screw that's tied to the CNC machine, so I can dose it digitally out of like a little, not quite a hypodermic needle, but those like quarter bayonet twist lock. Yeah, so it's coming out of that right on. Like I'm winding a single strip of fiber that's less than 6 mil wide at a time, and I'm dosing the fiber right onto that.
Wow.
Before it goes onto the mandrel. So that allows me to maintain the resin to fiber ratio that we need quite accurately, and it also doesn't work in as much air. So most filament wound tubes, they cure them right on the mandrel with like a compaction tape. So that's how you get your consolidation. The issue there is all that air you worked into there, it still lives in your composite. You're not getting it out at that point, right? So that's where we go the next step of removing them from the mandrel. They're on a polyethylene sleeve at that point. So I take the mandrel out of the middle. I've got this sock of fabric that's now wound with resin in it, but I've got a couple hours to work with the resin. So then it's then transferred into the molds. And they're placed inside a vacuum chamber with the bladders inside of them. So I pull vacuum on it for some amount of time. That's like, there's some proprietary stuff we do. And then at some point they get pressurized. This resin will cure at room temperature. So I don't need to worry about thermal expansion in the molds or kind of cumbersome heaters inside the vacuum chamber.
So you can still use an aluminium mold, presumably, right? And I've seen the finish that comes out of your mold is basically, it's a shame that you overcoat it with the coating afterwards, because the mirror finish that you get from the molding process is ridiculous. Like,
thank you.
And and like I said before, if you want to see these artifacts, go to John's Instagram or Framework Instagram, and you'll see what I'm talking about. But you pressurize pretty high. Is it? I think normally in the bike industry it's about 110 psi, but yours is a lot higher than that, right? 400 psi.
We're using air, so I have a pressure booster. It kind of works the same way a hydraulic cylinder does. I put our shop air into it at whatever it is, 120 psi, and it'll give me, I think, 3.8 times pressure on the outlet. So, yeah, you'll hear some indie builders who use like trap rubber molding say they hit 400 psi, but they're just calculating those numbers based on math.
I see.
How much thermal expansion they've got in the rubber in there. But like we've got pressure gauges on it. We know we're hitting 400 psi. The other thing is like you can't really hit 400 psi in your composite if you can piss the resin all out of the mold. Right? Like it's just not. So at some point, So that's where the timing comes in this stuff. Where I can hit it at a viscous state where I don't have a lot of flashing.
Right.
On most composites, in like take a prepreg system, if you pressurize them to 400 psi and your mold isn't like
tight,
not Yeah, basically like vacuum tight, 400 psi on liquid. It's gonna, when it's
just
as
leave.
thin as it is at it's just gonna leave. So you end up with too dry a composite.
Right.
So the ability to control the pressure at a phase where you're getting the resin doesn't want to flow as much. That's critical to how the tubes come out so well.
Okay.
And then so after they're out of the mold, that's like I start in the morning or the afternoon making a set of tubes. They stay overnight in the mold in the vacuum chamber. The next day I then remove them, and then they go into a post-curing oven for a elevated post-cure. The oven has, like, I don't know if you guys have it in the UK here. It's a product called like Mike 6. It's like an aluminum jig plate.
Is it?
It's just like fly cut on massive machines. So it's relatively flat. And so they get cured in this oven where it ramps up to about 90 C over the course of 8 hours. And I have like temperature profiling in there and comes back down very slowly.
Okay.
To get like the best possible mechanical performance out of the matrix system. Like most composites benefit, or most thermosets benefit from an elevated post-cure.
We talked before about Atherton bikes in the UK, based in Wales, making downhill and enduro frames. Seem to be very, very strong because Atherton, the guy behind the company, he breaks his body more than he can break the bikes. So they are built super tough. And you've said to me before, you don't really think 3D printed TI is a nice, well, I mean, of course it can be made strong enough with safety factors, right? But the sort of discontinuities in the grain structure and stuff doesn't really lend itself to making pure, mechanical parts, in my opinion. They seem to make it work. They've got the double lap joint in the lugs. So if you don't know what I mean by that at home, it's if you plug your carbon tube into one of the lugs, instead of just having it bonded around the outside, it's bonded on the inside and the outside. So it's like a socket. They state that a lot as being, the highest strength way to do a bonded tube. We were talking about why you don't use that. So let's
that joint style or printing versus.
Both. So let's talk about why you don't favor 3D printing at your production level, because it seems to be although it's expensive, it seems to be a production process that suits your kind of output or Atherton's output, or whether it's Bastion in Australia.
Yep.
And the double lap joint, briefly mention why you don't think that's necessary. In my opinion, I think that's more to do with actually strengthening the TI lug instead of the bond.
Let me talk about
Yeah.
Yeah, so for sure. Obviously the first comparison is to all the boutique places using 3D printing. Like the number of times I've been riding out and someone said, "Hey, is that a Bastion?" Right? Like they're well known. They're doing something cool. So my background coming from aerospace, I was also, like I told you this, I don't have a PhD in mechanical engineering, but I did 2 years of it. And one of my supervisors ran, it's called a light alloy casting facility. So my background coming from machining and foundry was kind of my two research supervisors were one deals a lot with machining, the other with kind of alloys. And then I was a visiting research at a place here that's called CanMat, like the Canadian Materials Laboratory. So in academia and manufacturing, the buzz has been 3D printing for longer than I've been doing this, I think. And the direct metal laser systems create a part that I would say I would put on par with like a very accurately made casting. So the thermal processes that occur inside that machine create a grain structure in the final product that has potentially porosity and inclusion. So like when we were dealing with stuff that was validated for aerospace, the type of tolerance control you needed on the machines and the powders and everything going in them was just like, it's really hard to replicate that. They were basically had to throw out the powder. They couldn't recycle it because when the laser blasts, like, yes, there are places that recycle it and sift it and go to great lengths to try to minimize that. But if everything is about your melt pool developing from the laser concentration and the size of the basically powder that's in there, if you've got something where the bead left over from the last one is slightly bigger, it's not going to melt the same. And then you've got like a nucleation site for problems in there. So I think there are a couple things that I don't like with 3D printing, but I'm biased because I machine stuff, is I think it's often kind of like a solution looking for a problem. Like I jokingly say, like 3D printing is bad for your brain. Like it makes you a lazy designer in some instances. But I machine stuff that I think other people would say you can't machine that practically. So Yeah, there's the material property side of it. I think is, you mentioned it though, as long as you build with enough wall thickness, you coming back to like the FEA, if you were to just plug in the properties for billet tie, like titanium, it's not going to transfer.
Yeah.
Well, yeah, it's not going to transfer. So your wall thickness needs to be kind of the same way it would be in a casting, where you're saying for both your fatigue and crack propagating, that thing is essentially overbuilt from what it should be on paper. That's not really a problem. Again, we've mentioned, like, you and I are both people who don't really think that 50 grams here or there, 100 grams on a bike frame matters. But if you're trying to optimize for that, you kind of can't. So then the other thing they need to do is fill them with a ton of infill throughout the whole lug, which is, it's both a feature and kind of like you're doing it because the stuff isn't as strong as a piece of tubing, tie tubing you get off the shelf. And that's okay. That's just a trade-off. Where it fell apart for me was like the way I'm trying to build the bike and the accuracies I need, I would still need to machine the thing after it's 3D printed. Like, their dimensional tolerance is good from a casting standpoint, but it's nowhere near a machine component. So you want to put bearings into it, you're going to have to fit. You want to put threads in it for your bottom bracket, if that's how you're doing it, you need to machine that after. The other thing is, it's just crazy expensive and slow way to make a part. So if I had to define it, if I had to say it like succinctly, I think it's a really expensive way to make a less than ideal part. There are a lot of instances where you're dealing with like stuff that truly can't be made another way. It's like there's no argument. You just have to go with additive. It's not that I hate additive. It's that I think our bikes are expensive, but I don't think they're at that price point. And if I was going to be 3D printing, in my opinion, I'd be putting out a worse product and it would cost more mechanically.
Fair enough.
So, and then it's also just like, I started this as someone who's run a business and wants to present a value proposition to the correct consumer. I don't like the bike brand, the bike world doesn't need another middle-aged white guy making a boutique bike that I'm differentiating exclusively on branding and what I'm telling people, right? Like, I'm trying to do something that is actually different. Whether or not people give a shit about that, that's up to them to decide. But like, I don't want to do a welded tie bike, right? Like, there's so many good options out there. Who am I to just throw my hat in the ring? And it's like, I'm not adding any value. So part of it was like, do it different and see if you can stand on difference alone, essentially. Like, I think the product is really good and I want to tell a good story about it, but like, I'm not a branding. The thing I didn't realize going into the bike thing was how much of it is just kind of like a luxury goods marketplace. So like, so much more marketing, so much more branding compared to just technical merit. And so your opening question about why me is like, not a lot of YouTubers are going to go into this level of detail on like what makes my bikes a little bit different. And again, I think it's totally fair to, like, I think my favorite people who follow us on Instagram are the ones who say like, not for me, either price point or whatever, but like what you're doing and I'm still going to follow along. I think that's pretty cool. So, and like the early on and even to this day, like a huge chunk of our followers are just other frame builders. So I think that's usually a good sign if you're doing something that's like at least worth watching.
Fair enough. What do you think about the high profile? I don't know how high profile it is, because I think downhill mountain biking, although I'm a fan, isn't that widely watched by my audience. But there was a lugged bike that quite famously snapped not too long ago in a race. I can't remember which one. I think it was one of the Crankworks races. Byrne and Kerr's Pivot, which is essentially a custom-made prototype with carbon tubes and aluminium lugs. Very similar. Well, I'm not saying it's similar to yours because I don't know the quality of that. I've not seen it. Well, I've seen them up close, but I've not seen it inside it. But basically, the head tube left of the frame. I mean, let's make no bones about it. That guy Bernard Kerr is one of the hardest hitting like riders you'd see on the downhill scene. The impact was significant, probably about a 50-foot gap, which he didn't clear. And cased it. Yeah, let's make no bones about it. One wheel on one side of the lip, the other wheel on the other side, and the frame just went, no thanks. Interestingly, that frame design has a parallel entrance for the down tube and the top tube. So basically, it's not constrained. So if the bond were to fail, the head tube could just pull off of the tubes. Traditional road bike lugged frames aren't like that. You have basically when you glue it together, if I'm not wrong, you basically have to glue everything concurrently so it slides together in one piece. You have to slide each bit so it can't detach. Apart from that obvious, I mean, I think it's a design flaw if it's like that. what could you say about? Do you know anything about that failure? Is that something people need to worry about?
Well, yeah, like my Instagram DMs that day or like the week after it happened was like, did you see this? Did you see this? Like, we talked about it at the time. I think my initial takeaway when you kind of like, there was some really grainy slow motion, well, not slow motion, but they're just like kind of
slowed
image
down
by image. Yeah. It was so clean, right? Like the carbon was intact and you could see the adhesive on it. And the lug was a separate piece with like no bits of carbon in there. So to me, that just says contamination right away. It's like for it to come out that easily. And I think that's what they ended up saying. And so, yeah, your point about that, I don't know if it's a failure in design that they leave together so long as they validate it to take the loads it needs. But it's definitely a nice safety belt to have them at different angles. So even if your joint does loosen, the thing kind of wedges itself in place. It can't come apart. Now, like you said, that the loads that guy hit, even if they were at two different angles, is like it might have. Yeah. So I think the design choice there is I'm not making mountain bikes, but it's to give you that suspension travel clearance up to the frame. The
front wheel. Yeah.
Yeah. Like if you just draw the straight line, you can't. So yeah, like to say that it's a design failure, I'm not sure. It's like maybe that joint needs to be way overbuilt because it's got like a, that is the direction in which the adhesives are the most strong. It's basically pure shear. If you want you want to be pulling it straight out. So like, I bet like the way he hit it, he probably like contamination, the tube's buckled with that much load and they kind of like pull away. So I think we totally skipped over the double lap joint in the last question. So I think like the advantage for the Atherton bikes, and I think Bastian does it the same way, pretty much anyone 3D printing, why not? You've got that ability to add some material there. What the main thing that helps, it's not necessarily that you've got twice as much glue surface area, it's that the carbon tube can't pull away from the outer.
Can't buckle locally.
Yeah. So that's the biggest issue we have is dealing with that because I don't have a metal ring in there. The downside of a double lap joint like that is it takes very particular bonding practices to get it right. You basically have to vent the bottom of it or else you're creating a hydraulic piston.
Yeah.
And I don't know, like maybe those 3D prints are porous enough that it doesn't matter, but like you're pushing like if it's done accurately and you have bond line spacer in there, you're making a hydraulic cylinder. And if that adhesive that's already you've applied in there can't really work its way back up without creating entrained air in the bond. So that's my main reason for opting for the style of joint we do. The downside is that, you've got to deal with those loads that can't be transmitted into a relatively rigid metal thing. The other thing for me we've talked a lot about how I changed the tube shape is the biggest thing that changes rider to rider is the wall thickness changes. So my inner diameter of the tube there changes and it will be different. So this allows me to play with different wall thicknesses, butting, layups, without worrying about that needing to constantly change that diameter or shape to accommodate for the different wall thickness in the carbon tube. So that's that answer. So I think high profile for all the guys in your comments that are saying a bonded frame is a stupid way to make a frame. It helps give them ammunition, and it's like it was maybe not a great day for the bonded frame builders when that happened. But to go back to the earlier discussion on like ISO testing is like that frame probably would have passed ISO testing. It probably did. The loads he put on it in the real world are like there's the drop test that you do on frames that want to separate them that way. But fuck, man, like that guy hit that thing at speed. It's a big guy. Those wheels want to go.
Realistic. I mean, not helped by the wheelbase and the really, really slack head angles, which just make the loads even worse than that joint. But yes, that frame has probably been through tens of ISO tests just by him riding it in a couple of races before that race. So an extreme use case. I'm not sure I'll be doing the same on mine.
There's that. And then it's like frames break. Like you talk to the mechanics in some of those races and it's like, that's pretty high profile way to have it happen. Hopefully you just develop a crack somewhere and like when you're back in your tent, you can kind of move the bike away. But those guys are breaking stuff left, right, and center. It's not like the frame builders are negligent or it's a stupid way of doing it. It's just when you're taking stuff to such an extreme, the bike has to weigh like 6 kilos or, you're going to be threading that needle of like durability versus weight somewhere.
It does look like to me those frames, the lugs are not anodized. They look pretty raw, but I might be wrong. I'm not sure.
I think they are, but they're not going for longevity, right? So they're it's a prototype. Yeah, they need it to last a season or two, and that's again where the galvanic corrosion thing takes time. And again, like if they're probably using bond line spacers, and if they do that, like there's no reason that frame should experience that failure mode.
Yeah. Just moving outwards from the direct specifics, more at a macro level. In terms of road bikes, gravel bikes, the things that you basically make the most. Well, those are the two categories I'd say that you define framework by.
Yep.
It seems like those two genres now are in the mass production space are merging. And what we've gone for is kind of an all-road bike, which I could ride a road race on with the right wheels, and I could also run 40mm gravel tires. Now, my gravel tire choice would be much bigger than 50mm.
Yeah.
And it seems like bike categories are now just solely defined by basically two things. One is tire clearance, and the other is chainring clearance. Other than
I would say also head tube angle.
Head tube angle, right. But that's more of a preferential thing. But in terms of physical constraints and limitations of frame design, big companies like to market you different categories. So you buy one road bike from them, you buy an all-road bike from them, you buy an endurance bike from them, you buy an aero bike from them, and you buy a, bloody hell, I've been really marketed to. I just said Aero, which is actually a Canyon bike, so I've really been brainwashed.
They got you.
An Aero bike, and then you buy a gravel bike. But when we were talking about this frame and designing this frame, I was like, damn, this thing, there's no reason why it can't do everything. The only thing really limiting it was the chainring clearance to fit bigger tires. Because if I'm riding gravel, I want to be riding mountain bike tires, basically, like the 2.25, 50, 53, 54 millimeter tires that proven to be fastest on my type of riding, which is pretty rough. But that, I think, is the only constraint that really is limiting us from just making one bike to do it all. Is there a way, in the future, do you think there's a way around that? So you truly could have a gravel bike that could run big 50mm tires with, I mean, there are a couple out there that can do it with a very dropped chainstay, those weird sort of drop chainstay looking bikes. That presents a bit of difficulty for your construction method, but do you see in the future all these subgenres becoming kind of obsolete? And can you think of a way to truly do a big chunky gravel tire and a road bike all in one?
It's hard because you read the comments in the video you posted, and some people are like 40 mils, that's not a gravel tire. Other people, 40 mils they'd be fine to ride that as a gravel tire.
But hey, this is not a gravel bike, this is a road bike.
Yeah. I think interestingly, depending on the chainstay length, one of the restricting factors, if you still want to run 2x, is your derailleur is going to hit the bigger tires.
True. Yeah.
So that's what a lot of people overlook.
Unless you push the rear wheel way back.
Yeah. So that's one of your big choke points that a lot of people don't think about. So when you're talking about the tire clearances that we're into now, I'm calling that mountain bike territory.
Yeah.
So I've got a 3D model that's in like its infancy of a platform for a mountain bike. So we would do yokes near the bottom bracket cluster. That are still alloy and thin out quite a bit. I don't think I'd need to resort to the crazy. Again, it all comes down to like what chain line you need to be running, because that like a lot of you get into boost or even just pushing it out a little bit on like 30mm spindle, you can bump it one way or the other to clear certain things. But I think it's more of like a philosophical question of like, just because the bike can accommodate both configurations, a 2x skinny road tires and 50mm, like what is it? What does that make it? Does it ride well at either discipline? Like, you strike me as someone who would be fine to ride a gravel bike with a relatively steep head tube angle, and not feel like that's going to be too twitchy for me. But some people want like a super slack, take the hands off the handlebars and it's just going to plow forward and have that kind of wheel flop, low speed stuff. That's not going to make for a great road bike.
True.
So I think and then again, like if you're talking about wanting to get a 600 gram frame with UD doing most of the work, road bike, you can't ride that on a gravel setting and ask it to last very long. Right.
And so hit a rock and not brace itself.
Ish. Or like hit a big, like, I've gone over the bars on my bike on some like single track stuff, and it's like I would call it an all road bike. And you're stopping pretty quickly. So there's a lot of load going through the frame in those instances. So I think it's a lot of the bikes we build are in that kind of gray area, definitely. certainly some road bikes, like just 2x, only need 30. Like some of the Europeans still want like 28 mil tires, 24 mil tires. The number of questions I get about rim brake bikes and really skinny tires is like, there's still people riding that way. They just want to be, pounded by the asphalt, and it's not my thing. We do make bikes. Like I don't do rim brake bikes, but I do bikes for skinny tires. But our road bike, like our road fork, the spec road fork, it'll clear a 32 or 35 mil slick, no problem. And then the rear end for that tire clearance, you're gonna have no drivetrain encumbrances for any chainstay length or 2x. So it's when you start to widen those stays out, which we can do kind of at an infinite variability. You're gonna either hit your chain ring or you're gonna hit your tire, depending on which combination you're going for. So yours is about the limits for a 2x bike, I would say.
Yeah, that's why I spec'd, wasn't it? The widest possible tire for a 2x. Yeah.
Yeah, and you might find that depending on the size of the chain rings you want to run, your inner chain ring is actually the encumbrance we have often is really close to the bottom bracket cluster. It's where the lugged section comes out, is that will hit certain spiders, but the chain ring will clear whatever 2 or 3 mils or inches radially out from that. So that's the thing you got to watch for on some drivetrain manufacturers. So I think it's tough to answer the question in a meaningful way of I'm sure you could make some sort of Franken bike that accommodates both. It's certainly going to look goofy as hell with road tires in it if it can clear 55 millimeter tires. But hey, some people want something functional. The reality is at our price point, most of our customers aren't trying to optimize their purchasing decision or rationalize it by I can get 2 bikes for one in terms of functionality, therefore I can stretch my budget a bit. It's this is a high-end product, right? It's not for everyone. And I will just say though that your bikes can be built up with a sensible build for much less than what a Top S Works or Trek could be from a shop. This I find it would be my main selling point about your stuff, is that you can get custom geometry in a top end bike, and if you're prepared to take maybe a step down from Dura Ace to Ultegra, which let's be honest is fuck all difference, you might as well get something custom and have some change to spare, because these top end bikes now are 15,000 USD. Not custom, maybe have QC issues, maybe have a creaky bottom bracket, so yours is an expensive product, but I think, and that was one of my later points I wanted to make, I think your bikes are good, they're good value, because that's
they're
kind of what
less
I wanted
expensive to build up. Cheap, not a cheap set of Chinese wheels, but a set of Fast Force wheels with the biggest, one of the biggest carbon rim manufacturers in the world, with DT Swiss hubs, Sapim spokes, and Ultegra. Your bikes could be done for 11,000 USD, fully built, and so you've got 3,000 USD in change.
Part of what I wanted to do with the offering was give the consumer the option for a really large portion of what they spend on the bike to go to actual manufacturing quality. Your typical big brand bike, not a lot of the dollar value that the consumer hands over at the bike shop is going to actually making the thing, right? It's the whole supply chain to get it there. It's the development, the marketing teams, the pro teams they're sponsoring.
Pro teams,
your dollar doesn't really get you a lot for how expensive, flagship bikes can be. In my opinion, if you want to get into it, but there's the world goes round, and those people are still selling plenty of bikes. A lot of that is, again, to my earlier point of the kind of luxury goods marketplace. Is some people want that decal on their down tube. They want the S Works and what that signifies as a kind of a status symbol in a way. And I'm certainly I would love to be one point get the brand to kind of status symbol, but not to be known for that bike just costs a stupid amount of money. It's actually a heirloom quality object. That bike is luxurious because it's well made, not because of how much was spent on it.
I think there's a bit of a kind of stigma attached to custom boutique bikes being for the slightly older generations, or people have had racier bikes, or ex-racers, or people just want a comfortable bike to ride. But let me just remind the people that if you want a fast bike is one that fits you really well, and 95% of the aerodynamics, which is what 80% of our effort is spent against when we're pedaling, is your body position. And the custom geometry allows you to be really, bike fit well into a very aerodynamic body position. It doesn't matter about the stupid knacker profile seat stays that your S-Works has got. That is we're talking those are the last tenths of the percent that you want to be looking at. But the bulk of the aerodynamics and the bulk of your speed or your capability on a bike is your body position, how aerodynamic your body position is. If your body doesn't fit the off-the-shelf Cervelo S5 or whatever, or you can't get handlebars narrow enough because they only make these one-piece ones where you can't adjust it, then that's never going to be as fast as a custom bike. So custom bike's not just about being relaxed because you're 60 and you want a TI bike. Like, it's speed. It's a speed option as well. That's why I set it as, to be honest.
A lot of our customers note PRs when they get on the bikes. Like, these are people.
We're not going to talk about Strava PRs. Yeah. We're not going that far.
Yeah. I don't know.
I'm happy to take it to a wind tunnel and test body position aerodynamics, but I'm not going to go claiming that I gave me a PB on Strava.
Yeah, I think it's like the new bike excitement, right? But your point about like some people's bodies just can't, like, I can't get into a particularly aero position. I just don't have the flexibility to do it. The thing that I would say can add to speed as much as getting your body in an optimal position is just comfort. Like, if you're uncomfortable, you can't put out power for a long time.
Exactly.
So that's like, yeah, we can make you a bike that's got you out like a plank, but if you can't put out power there, it doesn't matter. But if you're wanting to do you've got whatever goal it is, I want to do a 30 kilometer an hour plus ride for 4 hours. I want to try and hit that. You're going to have a hell of a hard time doing it if your body's feeling beat up halfway through it. So comfort without sacrificing power transfer is kind of one of the things I try to optimize for on the bikes. And it's like, people will ask about tuning for ride feel and all this stuff, and it's such a dubious thing to talk about accurately, right? Like, what a bike feels like to you and what you're looking for as a customer is very different than the next person. And to have a qualitative or quantitative way to communicate that person to person doesn't really exist. Yeah. So trying to make a very comfortable bike that you kind of just are happy to spend time on is what like a main design objective of mine is.
No, I think, talking on the comfort topic, I think a lot of people have not realized it, but we really miss being able to tune the comfort of our bikes these days, because the frame itself is basically a truss structure. It's very stiff in plane, so if bump inputs is stiff. And there are things you can do to make it bendy, the layout of the tubes, but just from a shape form as triangular, it's very stiff. And the two things that I would really tune a bike with is the tires, which has its own, many different variables like rolling resistance and damping and all these other things that you do affect by bigger tires or lower pressures. But the other thing is the seat post. And the in-housing production trend of frames over the last 10 years is that brands aren't buying seat posts from Deda, Thompson or Ritchie anymore. They're just doing everything in the frame builder in Asia because they're onboarding it, it's cheaper. It suits their aerodynamic marketing claims to make a D-shape integrated seat post, but you can't tune those frames anymore. So traditionally, if you had a round seat post 27.2, you could make that bike feel really stiff if you went and bought a Thompson Elite seat post. Or if you wanted it to be nice and whippy, you go and buy a Mega Light carbon seat post, and it completely transformed the ride quality of the rear end of the bike for the same tire pressure. But now with like the integrated bikes with the proprietary seat posts, you've lost that option of tuning the bike. And it's the same with the handlebars, because a lot of the the mass-produced bikes are coming onboarded with the integrated Aero bar and stem that has one stiffness value, can't be tuned. The only way you can tune it, fit a wider bar, mainly get a little bit more flex out of it. But with your frame, normal stem can be fitted, normal handlebars. You can choose a super lightweight, carbon bar or a very stiff, cheaper bar, and it's just way more tunable. And I think people have forgotten about that tunability that basic frame shapes allow you just to have a round seat post that you can change it up with. And one thing I'm enjoying, I'm going to enjoy doing is seeing how different seat posts react in your frame to kind of tune the comfort, because I think your frame will be in plane slightly more flexible than the off-the-shelf ones because of the lack of the 0 degree UD that's in there. So maybe I can go to a stiffer seat post, maybe.
Yeah, like the whippiness of the frame is like where you perceive that from is like, I would qualify that more from the bottom bracket than the saddle. To me, it's like the original bike I made is like if I'm climbing a hill on it, it's a fixie. You can feel that thing swaying underneath and kind of loading up. So it's like if I'm in a low gear ratio and I'm just like I am because it's a fixie, you keep on the pedal, you can feel it kind of unwind and shoot forward on you.
Yeah.
So to me, that's like whippy, getting beat up in the saddle. Like the way that most of those seat posts are made is the exact opposite shape you would want it for comfort, right? You'd want your aero profile going perpendicular so you can move forward and back, but you're not losing. Like good power transfer on the bike is partially at the saddle. Like if you're having to use your core stabilizing muscles to keep your hips from swaying side to side, you're wasting energy that could be going to the pedals. So you really want a saddle that doesn't rock side to side, but that moves front to back, which is the exact opposite shape you're talking about. It'll move side to side relatively far more than it will for comfort. So I have a couple prototype seat posts done where we're playing with a layup that basically can flex fore and aft as much as possible, but side to side doesn't move as much, so that like you're not wasting energy trying to stop your body from swaying. Comfort, like even just serviceability or getting parts. To me, the non-proprietary seat post and forks just kind of makes sense. It in a lot of ways, it's a modern take on a bike with like the internal cable routing, disc brakes, all that stuff. But there are some more kind of traditional frame builder choices, like you mentioned, just normal stem, normal seat post as options.
Do you have any plans to make a fork?
Yeah,
because you're supplying Envy forks right now, right? Most of them are Envy fork.
Envy, or we source open mold stuff from a company called Speeder. That's who does our integrated cockpits and our like base level forks. And the quality, the facilities they're made in could be the same, could be right down the road. It's like they're top notch. They just don't have the sticker on them. So it depends what the consumer, like the customer, wants to spec out. We're talking about the fork mainly because I think that is, if you want to talk about a gravel bike and tuning, there's only so much you can do for front end comfort without either having control of some type of suspension seat stem or being able to play with the fork. Because it's like you've got a rigid structure coming up from the front wheel and you're on your handlebars and you want to have comfort going over nasty stuff. There's only so much flex I can play with in the frame. And it could be that it's a very ambitious project. Honestly, the fork is like one of the most challenging parts of the bike to make. And I give a lot of respect to people that can get that done in a safe manner because it's such a safety critical thing too, right? It's like if that thing goes, you've got, So it's something that I want to aspire to doing, and that we're like making the tooling is relatively simple for me. The thing is just like, what do we do on the composite side of stuff? I'm decidedly not running pre-preg here. So we're kind of looking at experimenting with using the filament winder to basically make various sleeves that assemble onto some type of mandrel into a mold and then are pressurized. So not totally dissimilar if you watch like the factory footage of how Time makes their forks with resin transfer. They're using braided everything basically, and then just shooting a bunch of resin into it to give
which makes them quite heavy. Not that I care about weight.
I
think the time frames are on the resin heavy side. There's excess resin in those things. RTM.
Well, whatever isn't carbon is resin, right? You're controlling the ID and the OD. So it has its merit. So when we were originally developing the tube and switching from pre-preg to wet winding, I had considered doing resin transfer. Just wrap it dry, put it in the mold, and shoot the resin in. The big issue we ran into is that carbon fiber is actually a remarkably good filter medium. And for the you can't use certain toughened resins, or they just kind of filter out wherever they are. So that to me wasn't worth the trade-off. And then it's again, you get into the thing where you actually have like a lot of consumable waste because all your lines and stuff where you throw them away each time. You've got your fill pot. You've got and then like I think Time just does it at ambient atmosphere. They're just pressure pushing it in, but to do it really well, you want to pull vacuum. Again, because as the resin's flowing through that fiber, it's turbulent.
So John, why are you using press fit? Why are you using a threaded bottom bracket? Come on, tell us. What threaded bottom bracket? It's the best way. Just hit us with that quickly before we go.
I know you're being facetious here, but it's
I'm not. I'm really not.
bearing alignment, it just can't be guaranteed with any other system. Now, like we aren't, it's I would say the distinction needs to be drawn in that I'm not using a press fit interface to put another cup in. I'm just assembling a bearing the way it's meant to be assembled based on the manufacturer's tolerance on the bore. So yeah, I think people who are in the know kind of find it ironic when press fit people say it's a stupid way, because inherent in a press fit system is what I'm doing with the bearings. Like your aluminum cup has what I'm doing. I'm just omitting the thread in the frame. So the critical part of getting the bearings to work properly are having them concentric and kind of coplanar, like coaxial. And you can't really control that with a thread, in my opinion. You can get systems that are pretty close, or where a sleeve is going to come from one side to the other. But if you can put a sleeve together by hand, any misalignment that's in the bearing or in those threads is going to induce a bending moment in that assembly. There's just no, over that distance on the type of tubes you're talking about.
Yeah, very thin wall tubes. They're not going to restrict the bending, are they? No.
Even if they're infinitely rigid, if it has sliding assembly in it, that's going to bind. And that over that distance is enough to misalign bearings. It's like you're getting into the nitty gritty. But so my take on it was like, I'm machining that bottom bracket cluster in a top-notch CNC machine. I can guarantee it the same way your hub is built, essentially. Most hubs. Why not do that? Why would I introduce error in the form of stacking tolerances? It's also a way stiffer connection to the frame for power transfer. There's nothing that's wiggling in there. It's not going to creak. If our bikes creak in the bottom bracket, it's almost always a drivetrain issue. You just hear it in the down tube, right? So yeah, they can sound loud because the bearing is right in the frame. There's nothing squishy in between them. So it'll resonate noises where, like, 9 times out of 10, if I've got a creak, it's because like one of my cassette is slipping. The interface hasn't been greased, or like I need to tighten stuff. So yeah, like for me, it's just how bearings are meant to be installed. I know I'm kind of fighting an uphill battle with that, as the winds of mass market are saying press fit is stupid. It's responsible for all these problems, where
you're just making a front hub basically in the middle of the bike. So yeah.
So like you can replace the bearings relatively easily. I always recommend using proper pullers and extraction tools, but if you are comfortable servicing your hub bearings, it's no different in our frame. Off the shelf, it's 30 mil is what it's spec'd for. The SRAM dub bearings are the exact same bearing. They just have a 29 millimeter race. So if you wanted to realm
6806,
who we get, it's a 6806 bearing is the 30 mil, but the SRAM dub ones are just like dash 29, or it depends who you get them from. We get those from Enduro. So yeah, SRAM will run native. Anything 30 millimeter will run native. And then for Shimano or Campy, we just make reducer sleeves that go in the bearings on the other side. So that's what I ship you with it.
Those sleeves are made by you, are they? Yeah.
That's kind of the one I would say downside. It's proprietary to us, but I've gotten in like I would say debates with people about, like, if you buy a bottom bracket from someone and it's pick a standard BB 386 Evo, you can't guarantee that all the parts in that bottom bracket are cross compatible with another manufacturer's. They might choose different seals. They might actually choose different bearing widths. So you're kind of tied into that bearing. Like, the main thing for me is it defines what products you can put through the hole.
Yeah.
So as long as I can offer compatibility with all the drivetrains that are out there, I think it's not such a big issue. And then the bearing life is dramatically improved because they're not fighting one another. And I've got no practical way of testing it, but I think it's a very free running system.
If you could only match the level of sealing of the plastic Shimano bottom bracket, and then I think you'd have the perfect solution. Because if you look at, cut one of those in half, you look at the cross section, what they've done with the labyrinth seal and integrating that with the top cap, which is the aluminium, the plastic insert inside the inner race, is very clever. But I still really rate that Shimano BB. I think it's one of the most unsung heroes of the bike industry. How it can take up crap tolerances and misalignment, and they run forever because they're so well sealed.
Well, I think they run forever because the bearings don't fight one another. I think the sealing is like a lot of people attribute bearing life to sealing because it's something that they can see. I can see contamination. I can see a seal. What they can't see is the loads that are being imparted on bearing when they're pedaling. So Shimano makes use of all sorts of O-rings everywhere, so that, like, even on where they're their spindles are pushed into their spiders, like there's an O-ring there, so that you can deal with misalignments and still get your preload. So that I think their system is good from sealing. I think it's way better, as you said, from dealing with crap tolerances on whatever bending moments might be induced in that assembly. So the bearings are not being asked to fight, like to load the balls in a specific spot. So I think that's the big takeaway. Like if you wanted to make an infinitely rigid, my bearings aren't going to go anywhere approach to like a really stiff sleeve, and you put it in a bike, I still think they're going to move, and that's going to be way worse than the Shimano system. Both from if you can't control the full assembly, you have to take it into account in your design. Yeah, so a really accurate bottom bracket doesn't take the crappy frame into account. You're not solving the problem. You're making one part of it better than it was, but it's not. Yeah. So they are, like, you talk to any mechanic that's been doing it for a long time. The downside for Shimano is they make it in so few frame interfaces, I think, right? Like I'm not even up to speed on, I don't think you can get it for a whole host of bikes, can you?
No, you can get it for the PF 86 or 86.5 or the equivalent mountain bike, which is 90, 91 or 92. But I think the problem is that press fit bottom brackets have got such a bad rap in the bike industry. It's because Shimano don't make that for BB30, PS30, 386 Evo, and then you're into buying one of these one-piece or two-piece metal ones, which, like you said, can make the problem worse. And they haven't really thought about the sealing very well. And then that's where PressFit's got such a bad reputation. But
it puts the onus on the frame builder to make a round hole that's concentric with the other side of the frame. And so that's relatively easy to do with the post-machining process and any frame material, but it's added cost. So I think that if they can just
seldom done.
If they can just put a thread in there and say it's someone else's problem, that's better for their bottom line.
Exactly. Yeah.
So I think people don't hate press fit; they hate the execution of it. It creaked, it moved, it ate bearings, it did all this, but that's probably because the hole in your bike frame wasn't round and it wasn't lined up with the one on the other side. So I think it's like if you told someone that they're going to put the bearings in their wheel hub with a set of threads hanging them outside of it, they'd look at you like you're insane, right? It's just like, so why is that a good solution in the bottom bracket?
Very true.
So we have played with designs where the bearings are slightly more inboard and we put a seal there. I've not found it to be an issue. Like the enduro bearings we run don't corrode all that much. Those end faces aren't really places where shit can pack on them. If you're in mud, it's going to kind of fall off. It doesn't work its way into a system where you can't wash it off.
True.
Like my thing is those bearings are as wide apart as you can get, which again adds to stiffness between the wider you can keep the bearings, the closer to the pedaling forces they are, the better their life is going to be and their efficiency.
Is there one part of the frame where you've gone, do you know what, that's good enough? Because when I look at the frame, I see there's so many small attention to detail areas where you've really gone for the most precision, like tolerance, or the most precise. Is there a bit where you've just gone, do you know what, that's good enough for the bike? That's good enough for the bike industry.
No,
you know what I mean?
I'm not like this. I'm on this stupid mission to like prove a point that it can be made well. It's just, again, coming back to using the CNC machines to do everything, and the rigid molds that we're doing the composites with is like that takes out. There's no more work for me to make a super precise thing than to mail it in on the tolerances, right? Like the machine has probing in it. It can measure the parts. It can update tool offsets and tweak things in. And like where I'm at right now is so far beyond mass market stuff I'm kind of tweaking. I'm a tinkerer at heart. I want to have fun with stuff. But I think for me, the big changes will be, maybe we do a mountain bike, play more with tube profiles, try to get characteristics. I think the thing for me where I started without many finishing options is that's what people want in the custom bike world. They want bright colors. They want flashy paint jobs. So I need to get better at doing that to try to kind of make it a more, more, like they got to be fun, right? Like if you're spending this much money on a bike, why not have some fun? I like the kind of subdued look, but you probably saw the purple bike that I've got going on. Like it's part of the anodizing was now I can offer color schemes. So I think that I've said it to you in a few messages as we've been chatting. One of the big challenges in making bike stuff is just dealing with the kind of lack of tolerances in the general industry. So it's like that was the impetus for the seat post. It's like I hate how most seat posts sit in the frame. it's not going to be a cheap seat post to make or sell, but I'm not looking to sell a ton of them. How the mounting hardware works on the saddle rails is something that is a part of it. And yeah, so it's to try to like keep adding things to the list of products we're making, whether it's just to kind of have a really curated final product or just to overcome some shortcomings. Like I'm not out there replacing, yeah, would it be cool to try to make a rear derailleur? Yeah, but like I'm never going to be able to make a chain. I'm never going to be able to make bearings. I'm never going to be able to make, you just got to draw the line somewhere, right? There's people that are really good at that. So if I can't.
If you were making 200 frames a month, let's say, how would you make them?
Scale, more machines.
Just same process, but more machines?
Oh, like sorry, I thought you were asking how I get about in my current.
No, I'm saying would you use the same lugged, or would you?
Are they custom frames or are they like a static design?
Let's say like static size. So you got four or five sizes. How would you go about doing that 200 frames a month?
Probably the easiest way to do it is an alloy frame, right? Like laser cut tubing, robotic welding.
But let's sticking with carbon. Would you still go with bonded lugs, or would you go to full?
You need to go to rigid tooling.
Yeah.
Yeah, I like. So that when people talk about my frames having joints everywhere, it's like the average consumer might not realize how many joints there actually are in the carbon frame they bought off the showroom floor, right? It's like
it's the few.
Basically, the higher end the frame is, the fewer molds it takes. Is the general rule of thumb. There's like one or two companies I know of that are doing a proper monocoque frame where they're literally laying up the whole thing in a single tool. Yeah,
but the whole frame down the center line is symmetric. That's the one drawback I think they had with the early ones, is if they made it asymmetric, it would warp when it came out. So they kept everything symmetric. So yeah, anyway, that's a moot point. Sorry, carry on.
Yeah. So it would need to be some form of, like, I really like Time's process. I think in terms of the boutique, like kind of bridging that gap between boutique and mainstream. I do think they make a good quality product. I don't think it's got like, I know people who are resellers for them, like their bottom brackets do have problems. There's like, it's just in any mass produced bike, unless you're post machining stuff, you're going to have, or bonding in aluminum, like a solid aluminum piece after, you're going to have those kind of issues. But I think that they do a really good job at making a bike that people speak very highly of. I think what I would want to do is still preserve a lot of those. Like one of the reasons that I chose like an alloy for each of the nodes of the bike, the lugs, is that they're generally places that are interfacing with other metal parts.
True.
And carbon is a really bad material for interfacing with metal parts. It's just too soft, right? So I would still, if I was doing an all carbon frame, I would still want to have alloy in those locations, like proper bearing races in the headset and in the bottom bracket. And, you know, whether it's just a bonded in sleeve that like UDH has sort of removed the need for the thread in the rear dropouts. It's just a hole. So, you know, that's a little bit easier on carbon. But yeah, it's really soft. Like that's the kind of Achilles heel of carbon. So I'd still want to maintain those tight tolerances things. So I don't know if that means special bonding fixtures. Like I think you could do a really clever job of not needing to post machine, but using like a linear rails to insert cups with the bonding agent on them, that they keep them coaxial in a certain distance and they live in the frame where they are. And you could jig the frame up in a way to have it, you know, you're pretty damn sure it's on center line and in the right spot. So I think that there's a video of Allied frameworks in the States where they show their bottom bracket bonding the aluminum cups in, and they use a system like that. I think they're doing a pretty cool job. But they're doing I think there's a mold for each part of the bike. Head tube, seat cluster, bottom bracket cluster, dropouts. So yeah, from a true optimization of carbon fiber, you want fewer molds so you can get the fibers actually running through there. But yeah, I don't think I have a firm answer. I think it would be a 200. It's still a carbon bike. And yeah, you're needing to use molding somewhere. For sure. Interesting.
I don't have any more questions. I've run out my whole sheet that I wrote actually. Unless you got anything you want to say, we can wrap it up. If you got anything you want to add.
No, I think we've talked about a lot today. So
yeah,
I'm curious to see how many people make it this far. And
oh yeah.